Hi everyone, welcome back. Let's see that one of the drawback of FCFS, that is convoy effect. Before going to the definition of convoy effect, let us solve this particular example using FCFS algorithm. Guys, so to solve the first one, I will try to draw the Gantt chart. So at the 0th time, P1 has arrived and it will burst time will be 30 units. So 30 units after completion it will exit. So completion time for P1 will be 30, and then by the time P2 and P3 are available, so P2 will comes first. As arrival times are same, the shorter process are giving the importance, right? P2 will done. So for 3 units, so it will be 33. Then P3 it will done by 2 units, that will be 35. So what is the scheduling length here? Schedule length will be 35. Fine. Now fill this particular table, means I am trying to perform the average waiting time. Right? In order to calculate the average waiting time, we need to have all the, so waiting time formula will be what? Turnaround time minus burst time. Right? So to calculate turnaround time, you have to calculate the completion time minus arrival time. So turnaround time means completion time minus arrival time. So what is the completion time of process P1? That is 30. Process P2 33. Process P3 35. Turnaround time means completion time minus arrival time. That is 30. Completion time is 33 minus 1, 32. 35 minus 1, 34. 34. Waiting time we can calculate as turnaround time minus burst time. Turnaround time is 30, burst time is 30, that is 0. 32 minus 3, 29. 34 minus 2, 32. So average waiting time is here 0 plus 29 plus 32 by 3. Okay, so then it will be 61 by 3, around equal to 20 units of time. 20 units of time is the waiting time for the first problem. Let us take the second one. So if I try to draw the Gantt chart, at 0th time, what are the processes are available for us? P2 and P3 are available. Out of this, which one will get the first chance? Lower process side. So P2 will get the chance for 3 units, so completed by 3. Then P3 will get the chance and allocated for 2 units of time, so it's completed by 5. By the time P1 will be available, so P1 will be allocated for 30 units of time, so it will be completed by 35. So here schedule length will be 35. Good. Then we need to calculate average waiting time. Average waiting time means you have to get the turnaround time as well as completion time. So what is the completion time of P1? 35. Completion time of P2 will be 3. Completion time of P3 will be 5. What is turnaround time? Completion time minus arrival time. So that is 34, 3 and 5. What is waiting time? Turnaround time minus burst time. That is 4, 0 and 3. Which means average waiting time will be 4 plus 0 plus 3 by 3. Which I can say it as 7 by 3, which is around equal to 2.33 units of time. Right? Guys, if you are able to observe this particular example is providing average waiting time as 20 units. This particular example is providing average waiting time of 2.33 units. But look at the data what they have given. Arrival time of process P1 is 30, which is arriving at the 0. Whereas coming to here, P2 and P3 arrival times are 0, which are having the less process. Right? Clearly observe, here the bigger process is what? P1. Bigger process is P1. Here also bigger process is P1, but it has arrived at 1 unit of time. Here it has arrived at the 0th unit of time. Means in this particular example, bigger process is arrived early before the smaller process. That's why it is leading to average waiting time of 20 units. Whereas coming to this second example, smaller process are executed first, then given chance to bigger process. That's why we got 2.33 units of time. This is what we call it as convoy effect. Technically, if we speak, when a bigger process come first before the smaller process, then smaller process has to wait for long time. Am I right? Smaller process have to wait for long time. This is what we call it as convoy effect. That is what this example is clearly showing. Right? First one is clearly having convoy effect because the bigger process arrived at the early before small process. Whereas coming to here, small process given the chance. That's the reason to solve this particular thing, we are moving for SJF, shortest job first algorithm. Can this particular algorithm having starvation? No. Convoy effect? Yes. In FCFS, convoy effect is there, but starvation is not there. What is the general meaning of starvation? When you got any kind of higher priority job, always the current executed job will not be executed. That is what starvation. But that logic won't applicable in FCFS because FCFS means what? Whoever first in will comes out first. That's it. It won't consider priorities and all those things. So FCFS is free from the starvation, but it is suffering from the convoy effect. Hope you understood this video clearly. Thank you.